Hello, welcome everyone. I'm Kinga Petrovi, and I'm very happy to have you here for this very important talk on cloud computing. So I would like to introduce to you Faye Ardramondi, and Faye has many accomplishments. So I will only briefly go through some of her accomplishments, but she is the founder and CEO of mimik, a cloud computing, a hybrid edge cloud computing company that enables many computer devices to act as a cloud server. So I'm sure she will explain that in a much greater detail than I will right now. But Faye has many accomplishments. She is the official member of the Forbes Technology Council. She has been granted many patents and awards, and also has owned several and led several high-tech companies. She's joining us now from the Bay Area. But she originally, she studied in Montreal at Concordia, and in 2018 was also named as a notable alumni of Concordia. So that is really wonderful. And she has been named top 40 under 40 in the Distinguished Business Vancouver's 2006 awards. And the list just goes on and on. But I really look forward to your talk, and I will hand it over to you. I will just give a small reminder to those participating to please put your questions and comments in the chat, and I will moderate the chat and address those questions to Faye. So at any time, please do that. And now I hand it over to you, Faye.
Thank you, Kim, and thank you, MTL Connect. It's great to be home again at Montreal, even if it's virtually. Montreal is dear to my heart, and I spend a lot of good time, obviously, at Concordia University. And it's hard to say where I'm originally from as a global citizen, as I'm constantly been moving around for work and life. So let's get into it. The presentation today is about whether hybrid edge cloud computing is ready for prime time. Before getting to it, but what is edge cloud computing? I guess the historical pendulum of computing been moving from centralized to decentralized. Obviously, we started with mainframe, where computer, and it's always about where computing is and where is it available, how much does it cost, and all that, and as the evolution computing is happening. So we started with mainframe as a centralized computing, then we moved to PC, where it was pretty much decentralized because applications and servers were running on PC. Then with mobile internet, we pretty much moved to centralized computing again, because the first generation of mobile devices had low computing on the mobile side, and cloud computing was actually providing the ability for servers to be hosted in cloud computing. But we're now moving to decentralized world again for many reasons, where we're going to get into it and why. And mainly it's because you have much more computing is available on device side. We will cover that in a second. Now, mobile internet was about, as we discussed, mobile connect to internet to consume content. That was the first generation of applications that we saw. So yes, mobile internet was about connecting messaging and application. But today, pretty much when your mobile application connects in order to get information, the data constantly travel through cloud. The best example is, imagine you want to go and grab some information from your kitchen, but you have to leave your home before you come back to the kitchen. So think of it as this way. And obviously, with tremendous amount of data, we have many issues with that architecture as we are transitioning to a hyper-connected world, which includes latency, includes data privacy, includes data security issue, energy, and cost. So this is the path between your mobile application to your when you utilize your application and everything you do, the data travel between your device to where the application backend is, which is cloud. What we're showing here is more about latency, but what I like to also point out to everybody, and what is something that I've been looking at very closely recently, is all the third-party aggregators that are part of your application, and they have visibility to your data. So, and we don't see them as consumers of those applications. We really don't see who's between me and my application, which third party is using, and who's actually looking at those data. Now, as we move to a hyper-connected world, the traffic patterns are changing. It's no longer about your mobile connect to internet to consume content, but digital intersect with every aspect of your physical life. It's around us. It's your thermostat, it's your solar panel, it's your car, and everything is going to have a combination of AI, blockchain, robotic, and smart mobility. So it's no longer about communication, one-way communication, but data and knowledge need to be exchanged. It's going to be very difficult to actually, to us, what we're seeing is that this is almost like going to the end of the era of app economy to a subscription economy. It's going to be difficult to separate apps from each other because it's actually systems that need to exchange knowledge. Your thermostat needs to grab information from the solar panel. Your car is part of the devices that you own when it's in your garage, and then when it's on the road, is part of devices on the road. It's about knowledge exchange with other cars. So therefore, we cannot send information to cloud constantly and back. We actually have to turn the device and where the journey of data starts into a cloud computing. And that's what the hybrid edge cloud is actually come to reality, because now every device has its own cloud capability, and as devices are increasing in computational capability, connectivity, storage, memory, this becomes more and more of a reality. The challenge is today, edge is a bit of a confusion as well, because everybody's trying to say, hey, this is a near edge, missed edge, far edge, true edge. So it's a bit of a taxonomy disaster of it, so chaos or confusion. And we always refer to that as a blind man and elephant story, where basically depending on which industry you come from, you may consider edge that sector. So it's a telco edge because I own base station. It's a gateway fog computing because I put router in customer home. The way we looked at it is really about continuum computing. It's about data journey. Again, when you look at your application running on the end device and there is computation capability, that's where edge starts, with the journey of data. And then every resource on the way become a resource, cloud computing resource. So now you'll be able to have applications communicating with each other between two different devices from the microservice point of view. And then they can also utilize every other resource within the proximity, such as a base station or an Amazon wavelength or others, and regional data center and eventually cloud. But the point is there is a lot more computational capability that are available on devices. Today, your iPhone or Samsung mobile phone has more computing than a cloud server or a server a decade ago. And the same thing is happening with headless devices. The truck that delivers your goods have computer in it. And the way to think about it is that truck no longer just carry my goods. That truck is also carry the information with goods. So information and digital, again, intersects with physical, and therefore the digital solution need to mimic the physical interaction and exchange knowledge and data with each other. So I always look at this pyramid. in terms of cloud resource. At the top, you have central. At the bottom, you have this tens of billions of connected devices that come to market every day, and billions of applications running on them. That's where we call edge to cloud, and the two meet in the middle. There is always going to be room for both, and that's what we always talk about, hybrid edge cloud computing. The benefits of that, the benefits of using hybrid edge cloud is really tremendous. And it's not about a killer app, it's about hyper-connected world. The benefits are from resiliency of data to, more important, data privacy, to environmental impact, more energy efficient, and faster time to market, and much lower cost of cloud. And one thing that I want to point out, because it's always come up, the battery consumption on the edge device. And the power of sending data over RF link is much more power consuming than the power of processing data on device. In fact, there are data that you increasing the efficiency of power consumption by maybe even 20% when you're processing data where on the same device that the data gets created. So now, what is hybrid edge cloud native app development? We're constantly hearing about cloud native app development, which pretty much refers to this notion of microservice development. The first generation of solutions was about monolith app. You have a monolith app on device, you have a monolith service, software services that run on cloud. Cloud 2.0 has been about microservice architecture, where you have macro systems. So it's no longer about monolith, but the composition of monolith to microservices. Now, when you look at banks, when you look at government solutions, right now there's a lot of challenges on upgrading their monolith system to microservice architecture, because these are truly legacy systems. Some are even written with COBOL languages, which there is a shortage of talent in COBOL. Some of you may not even know what COBOL is. Now, we've been utilized in industry for that legacy to modernization, because now when you can bring that notion of microservice, where it's about task running on a cloud compute, you can start it from device, and you can reduce the burden of all of a sudden trying to convert the entire monolith system in the backend to microservices. So you can utilize the computing on device, and you can start bringing logic and put it on device and extend the legacy of the backend. That's one way that our technology has been utilized. And obviously the advantage for mobile device vendors is that there is now the better justification why these mobile devices cost so much, and the compute and power and memory and CPU are being utilized for extending, for modernizing the legacy app into a microservice architecture. The other place that's been used today and commercially available are wellness and fintech applications. Today, you download a wellness application or a fintech application that you're using in the consumer side. Your application on the device side is probably monolith. The backend of that application is running in cloud. Now, the companies have came and basically took their architecture and started bringing the microservices to the device side. And by that, they reduce the latency of communication for their consumer. By that, they reduce their cost of cloud by up to 90%. And by that, they added granular data privacy, because again, you can now process data on the same device. A smart home solution. Today, we're utilizing a smart home solution to prevent physical intrusion. But in reality, we're vulnerable to digital intrusion because your data is constantly going in cloud. And we just witnessed when internet gets disconnected, you no longer have your protection. Now with Mimic, what we're doing is that, and what's been utilized is now the two devices can discover each other between a thermostat and a mobile device, and they can share knowledge, which means if you don't have internet, you're not losing your complete vulnerable, you're no longer vulnerable to physical intrusion. But now things can work even without internet. And you add dynamic granular policy. Today, when you put a smart home, your kid can control your entire home. But with this architecture, you can assign granular policy to every user, to every stream of data, to even visitors. Assign policy to visitors and they take this away. If my maid come home, or if my nanny, or if my mom wants to come home, I can assign that at this time, give access to this person. And when they enter the house, things get checked peer to peer. And when I need to access remotely, I still can do that. So it gives me a lot of flexibility, security, scalability, and privacy. CCTV cameras today. Every camera streams to a NOC center. And then when they monitor every stream at the NOC center, and then when there is an event, they inform the law enforcement to be dispatched to that location. By the time that the law enforcement reach that location, probably that event is no longer occurring, and the cost to our privacy, that everybody's monitoring every move that we make on the street, is quite nerve-wracking. But how can we solve that with the hybrid edge cloud computing? Now the model of an intruder or someone who we are looking for can be dispatched to cameras, and the camera is looking for that AI model of an intruder. And the moment the camera detects it, it can dispatch it to another camera within proximity, and it can dispatch it to a law enforcement with the location and coordinate, so that the closest law enforcement can be dispatched to that location and they can monitor it. Efficiency, lower latency, full privacy, more flexibility achieved. Now, there is another thing that we're coining the term as called edge native mashup. We all remember the mashup of the web world. Now, today, you have a tax application on your device, you have a healthcare application on your device, and you want to make a payment through that application. And the way that is done, you have a third-party library in your application, that third-party library send your authorization to that third-party backend. That third-party backend send authorization to the bank backend and says, hey, Faye gave me authorization to access information and make this payment to this healthcare application. With Mimik and with this edge native mashup, you don't need to do that. And by the way, on that moment, most probably the third party now seeing every stream of communication with your bank that you're having. Now with Mimik, what we have enabled to do, and this is also part of some of activities with partners such as Flybits, that also a Canadian and Toronto company. What we now achieve to do is now the authorization between my healthcare application on my device and my bank can happen on the same device versus the data leaving the office. So whether there is about legacy optimization of application or creating new experiences, the future is about knowledge exchange, and the future is about cross-system, cross-OS, cross-network, and cross-cloud communication in order for us to drive to an ethical, AI-driven, fully automated with data privacy and increase profitability of the business models. So that's about that. I only have one more, perhaps few more seconds to talk about this. Check us out. We strongly believe in ecosystem play. We strongly believe that the future need to converge to a sustainable digital economy, that every contributor is basically get benefit and get profit from their data, from the applications that they're using, from the code that we're developing and putting it in open source. And we're here to work with the ecosystem and create a better digital future for all of us.
Thank you so much, Faye. That was really, really interesting. And I wish we could have gotten into questions, but unfortunately the time has run out. But thank you very much for sharing that important work. And the website, of course, is there, and different ways of connecting for people to find out more. So
absolutely. And this afternoon, we have a session with Kathy Wood around disruptive innovation at 12 o'clock. So please, 12 Pacific. So please join us.